previous video, we talked about how to calculate the determinant of a 2x2 matrix. So now we're going to talk about a third order determinant. So this will come from a 3x3 matrix. So I'm going to show you the general formula, and then we'll do a couple of practice ones. So the longhand way to write this out would be, we're going to copy down this matrix 4 times, and we're going to kind of pair them together. So I'm going to write it 2 next to each other, and then we're going to have our subtraction sign, and then I'm going to write the other 2 matrices. So when I'm writing this, the letter stands for the column that it's in, and then the subscript is the row that it's in. And you want to be fairly neat when we do this, because the diagonals and easily identifying them is going to be important for this problem. All right, so there's my first one. So now I'm just going to rewrite this next to it. And then I'm going to put in my subtraction sign, and then I'm going to rewrite this group again. And this will make sense why we are doing this when I start showing you how we are going to get the formula to find the determinant. And I'm going to show you a shorthand way to do this too, so you don't have to write your matrices out like this every time. But again, to start with, it's easier to see. Oh my goodness, A. Okay, so we got it written out. So just like with our 2x2, we have to multiply the forward diagonal, and this is going to be diagonals in this case, and then we're going to subtract the product of the backwards diagonals. So we're going to have a really big bracket to start with. Okay, and then I'm going to start with that forward diagonal. So I'm going to go right down the middle of my first matrix. So we're going to take A1 times B2 times C3. Okay, so this is going to be A1, B2, C3. And then we are going to add that to the next diagonal. So it doesn't matter when we start doing this which direction you go, but in this case I have to go into my second matrix. So I'm going to go up. So on our next diagonal, we're going to have to take B1 times C2 times A3. So B1, C2, A3. And then we have our third diagonal. Okay, so again, we're adding in between. So again, going up, we have to multiply C1, A2, and B3. So C1, A2 times B3. And then I'm going to close my big bracket. And then we're going to subtract the backwards diagonals. Okay, so again, starting in the middle, this time we're going the opposite direction. So A3, B2, C1. Okay, and then adding that to my next diagonal. Okay, so we are going to multiply B3, C2, and A1 together. And then adding it to the last diagonal. So that means that we are taking C3 times A2 times B1. And believe it or not, that is going to simplify down to a single number. Okay. All right, so that is the formula that we're going to do. So now when we have an actual matrix, so on number 6 here, we're going to do a shorthand version of this, but overall that's what we're doing. So I'm just going to write this one out twice. So I'm going to put my subtraction sign, then I'm going to write my second one. So this will be negative 3, 4, 0, 2, negative 5, 1, 0, 2, 3. Okay. So now what I need to be able to do is kind of recognize where this extra one is coming from. So when we start, we're always going to start down the middle. So we're going to multiply negative 3 times negative 5 times 3. And you don't have to write that out. You can just do that multiplication. So this is going to be 15, and then 15 times 3 is 45. Okay, so my first number is 45. Okay, and I am going to do my brackets here. So, and then we're adding and subtracting in between. So that's kind of the setup that we're going for. Okay, so now on my second diagonal, so if I go back up and look at my formula, so I'm taking B1 times C2 times A3. Well, that A3 is the single diagonal down here. So in a matrix, we're going to take the 4 times 1, and then I have to go to the opposite side of the diagonal and use the number by itself. So 4 times 1 times 0 is 0. And then I need that last diagonal. So now I'm taking my single one and then multiplying it by the one in the middle here. And again, I know I'm allowed to do that because of this. So when I take C1 times A2, so here's A2, and then here's B3. So as long as we are multiplying those numbers together, that's what matters. So 0 times 2 is going to be 0. And then I'm going to go through that same process for the backwards ones. So again, I'm always going to start right down the middle. So 0 times negative 5 times 0 is 0. And it doesn't matter if we go up or down first. But if I go down, then I have to take, so the 2 times 1, and then times the single number on this side. So 2 times 1 times negative 3 is negative 6. And then I have my last group of numbers. So I'm taking 3 times 2 times 4. So 3 times 2 is 6. 6 times 4 is 24. Okay. And then in each of our groups, we are just going to add all the numbers together. So this is going to be 45. And negative 6 plus 24 is going to be 18. So 45 minus 18 gives us 27. So 27 is the determinant for that problem. So I would like you to pause the video and try and find the determinant for number 7. All right, so again, I'm just going to write out my second one. So negative 1, 3, 5, 2, negative 4, 6, 0, 1, negative 1. And then I can do my setup right away. Oops. That should be a minus sign. And then adding in the brackets. All right, so starting with the middle, going forward. So we are taking negative 1 times negative 4 times negative 1. So that's going to be negative 4. And if we want, on this one, I can just multiply this right away too if I want. So 0 times negative 4 times 5 is 0. And then I'm going to go up on the side. So I'm going to take 3 times 6 times 0. So that's just 0. And then if I go down on this one, so again, it doesn't matter if we go up or down first. So 1 times 6 times negative 1. So that's going to give me negative 6. And then I have my last set of diagonals. So 5 times 2 times 1 is going to be 10. And then 2 times 3 times negative 1 is negative 6. Okay. So if we start adding, negative 4 plus 10 is 6. And then minus a negative 12. So really that means that we are adding. So my determinant for this problem is going to be 18.